welcome to the end of week 5. Our mini project for this week is memory. So memory is a card game in which you deal out a set of cards and you flip them over 2 at a time. If they match, you leave them face up. If they don't match, you flip them back over. The goal is to end up with all the cards face up. To build kind of a computer version of memory is not going to be too difficult. The code you're going to write is fairly short. However, you shouldn't underestimate the difficulty of this project. We're going to use some concepts that are kind of new to you, and so you should pay attention to this. In particular, we're going to use lists. We're going to use lists to kind of represent the cards and whether they're visible or not. We're also going to need to keep track of the state of the game. As you play a game of memory, where you are in the game changes. And so we're going to have to talk a little bit about how to kind of keep track of game state inside your games. I'm going to do 3 things in this lecture. I'm going to walk you through the program template for memory. I'm then going to show you another program that's separate that kind of keeps track of the game state inside memory. You'll need to kind of take some of the logic of that program and integrate it into your implementation of memory. And then the final thing I'm going to do is I'm going to invite in a special guest, and we'll play a couple of games of memory. Okay, let's go to lecture. All right, let's take a look at the program template for memory. So in fact, I'm sitting here inside Code Sculptor, and I've loaded in my implementation of the full game of memory. So you can see it's very short. It only requires 62 lines. Critically, I've used code folding here to hide the implementations of kind of the 3 functions that form the core of memory: init, your mouse handler, and your draw handler. So your job is really to only write a very small number of lines of Python to implement these 3 functions. Now, as I said before, this is going to involve a little bit of work because you're going to have to use lists in here. You're going to have to use a list to kind of store the contents of the various cards that you've dealt out. You need to keep track of whether the card's exposed or not, probably using a list with whose entries are Boolean, say true or false, on whether it's exposed or not. You're going to need to keep track of kind of where you've clicked and figure out which cards you're trying to expose. And then the last thing is you've got to keep track of the state of the game. And that's going to require a little more logic than you've done in previous games. So let's just play real quick, and I'll kind of show you how it works, and then we'll kind of focus on this idea of state. So we popped it up here. Our canvas is kind of very wide, but it's not very tall. I have a restart button, so we're ready to rock here. So I'm going to click. I have 0 cards exposed. I click. I expose a card. Click. I expose a second card. Notice if they don't match, the next time I click, I go back to 1 card exposed. I click, 2 cards exposed. If they don't match, I go back to the 1 card exposed state. Now, if I go here and click a 2, I notice that these cards pair. So the next time I click, I'm going to go back to the 1 unpaired card state. So notice now there's 1 card that's unpaired. I click, there's 2 cards that's unpaired. I now flip those over and go back to a 1 unpaired card exposed. So there's this logic that takes place inside the game of the form: I have 0 unpaired cards exposed. That's kind of the start state. Then I have 1 unpaired card exposed, 2 unpaired cards exposed, 1 unpaired card exposed, 2 unpaired cards exposed. So we're going to focus on that kind of logic, and I'm going to show you a little bit of example of how to kind of do this in a separate application. You'll have to kind of then take that logic and kind of move it into your implementation of memory. Let me point out a couple of more features here just to kind of emphasize what's in the mini project description and the grading rubric. There's a restart button that restarts the game. We keep track of the moves over here. We're going to actually have a label over here. We're going to use set text to update the label. Another thing that's very important is that if you've clicked on a card, all clicks on exposed cards should be ignored. I'm going to be pretty adamant in insisting on that. We put that in boldface when we had the project description up. This makes the game logic a lot easier. If you deviate from this, the template has a bullet for this, you're liable to be penalized. So I suggest you kind of stick with that. People like to make variants of this game. You're welcome to use images in place of textual numbers here. You're also welcome to lay this out in some kind of grid. That's fine. But the logic of how you kind of expose and turn cards back over should stay unchanged. So let's go on real quick and let's look at that simple application about kind of keeping track of the number of cards that are exposed. So I promised you a little bit of code to kind of show you how to actually control the state of your memory game where you either have 0, 1, or 2 cards exposed. So I've wrote a little application here, and I'm going to just run it for you real quick. So it kind of pops up a canvas, and it has kind of the name of the state here. So this is the 0 cards exposed. This happens when the game is beginning. And so I could kind of click this button and act like we had a mouse click. And what do we have? We have 1 card exposed. I click the mouse click again. I have 2 cards exposed. Now if I click a mouse click, I get 1 card exposed. And it just kind of goes back and forth. If I hit restart, we go back to game beginning. And then we go to 1, 2, 1, 2, and so forth. So how did I actually implement this? It's very easy. I have a global variable, I'm going to call it state, and it has 3 values, either 0, 1, or 2. And we initialize it to be 0. And then inside, well, our handler, in this case, we're going to have a button handler, but in your case, you'd use it in the mouse handler. We're going to have a conditional that checks to see if the state is 0. Then we go to the state being 1. If the state is 1, we go to the state being 2. If it's in 2, we make the state go back to 1. So notice what happens. 0 goes to 1, 1 goes to 2, 2 goes to 1. Now down here, I've actually made the draw handler do one of 3 things based on the value of state. In memory, the logic's going to be more complicated. You're going to have to go through and manipulate the array that tells you, the list that tells you whether a card is exposed or not in an appropriate manner. So that's going to be the subtlety involved in implementing memory. But my suggestion is you'll probably want to take this piece of code right here and actually insert it almost directly inside the mouse handler inside memory and kind of use that as a starting point to get going. So if you're confused on how to do game state, take a look at this example, and I think that'll get you started. Okay, let's go and play a couple of games of memory and have some fun now. Well, I promised you we'd play a game of memory. Now, my plan had been to have somebody with a eidetic memory come and join us, somebody you probably all know from the class and really, really like. But the copyright police actually foiled that plan. So instead, I've invited somebody else who has a eidetic memory to come join us and play a game of memory. Come on, Scott.
Hello.
All right, Scott, you want to play a game of memory?
Count me out.
What? Come on.
You want me to use my intelligence in a tawdry competition? Would you ask Picasso to play Pictionary? Would you ask Noah Webster to play Boggle? Would you ask Jacques Cousteau to play Go Fish?
Yes, I would. Especially if it's you.
All right, fine.
All right, we're going to play a game of memory here, and we'll see who's got the best memory. By the way, Scott, that was almost as good as Sheldon did. Just stay a professor. All right, well, we've got it loaded up here. Memory's ready to rock. We're going to let Scott go first, and then I get to go second. We'll figure out who wins ties when we're done. I'm hoping for a tie at this point here. All right, Scott, give it a shot here. All right. Okay, Scott, now you need to click in the green squares.
All right.
I want to make you laugh so much there's no way you can do it.
Oh, hey, see? I know what I'm doing here.
Is this going to be a replay of Pong again? I'm going to have to check this code afterwards. They say, oh, man, oh, no, I'm totally doomed. What is this?
Oh, what was that?
Hey, all right, oh, God. What is it? No, oh, my Lord. I'm doomed. Oh. That's what, something's wrong here. I think this is like for 6. Yes. All right. 15. I have a little bit of a chance. I don't think your memory is quite as photographic as you think.
Yeah. Well, at least I own more than one shirt. What's with that black shirt anyway?
All right. I can explain the black shirt. Okay, I don't think I'm Steve Jobs. Here's the difference. One, brilliant egomaniac. The other one founded Apple. All right? All right, I'm going to demonstrate. Well, we'll see. I'm not going to demonstrate anything except I'm probably really bad at memory here. All right, here we go. Come on, baby, be good. You got lucky there.
3, oh, come on.
No.
I had one by now. I already had one.
Oh, God, I'm like totally unmatched. 7! I'm totally mad. I think we're going to have a system crash here in a second. Oh, jeez. There's no way I remember where 6 was. Can we rewind the video tape here?
Nope. This is an easy victory for me, I'm pretty sure.
God.
I don't know what you're talking about.
Yes!
Oh, pulls one out.
Come on.
Come on, 3.
Yeah, you have no idea where that is.
Yes!
Yeah.
Oh, yes!
Oh man, this is looking bad.
6 squared with 6.
Nope. That's not it. It's not right there.
Ah!
It wasn't right there.
Oh, shoot.
Oh. Yeah, you have no idea where 1 is.
The truth is, I don't. Oh, yeah. Oh! 7. What was that? Where the heck was 7? It's there.
Nope.
Oh, no!
Nope.
All right.
This is it.
I have to do this
Better
one.
get it right. Oh.
I think it is! Oh, yeah!
Man, so lose by 1 to the Steve Jobs wannabe. I don't know.
Alright, that was totally unplanned, by the way. Alright, we'll see you guys next week.